Okay, we continue with question number 16. State the formula of conductivity. Sigma as unit. This is very easy. That's mine. Okay, so conductivity sigma is equals to 1 over resistivity. Okay, so unit will be, resistivity is ohm, right? Ohm. So unit will be per ohm and per meter. Okay, per meter. So resistivity is, remember, R equals to rho L over A. So we want to use this rho L over A. So there we have rho equals to A over RL. Okay, A over RL. Wait. It will be RA over L. Okay, rho will be RA over L. So A, it has m squared. This one in meter, m squared over 1. So you have here meter. Okay, meter power of minus 1, because we have meter squared and meter power of 1. Okay, 16b, current 3 ampere flows in a tungsten wire with length 3 meter and diameter. There are 340 3.4 T times 10 to the 8 free electrons per meter cube in tungsten. Calculate A1, the current density. Current density J equals to I over A. Okay, I over A is equals to 3 divided by pi r squared. Okay, so R is actually 1.50 times 10 power negative 3 divided by 2 and squared. So you have 1.698 times 10 power 6. Remember the unit is ampere per meter squared. Okay. Okay. And number 2, the drift velocity of free electrons. The drift velocity of electron I equals to Navi. Remember that. And I over A equals NVE. I over A is actually J. You can see it going up like that. Okay. So NVE. So we want to use the V here. So V equals to V equals to V equals to J over NE. So J is 1.6. We take all this number, 1.698 times 10 power of 6 divided by the number of the tungsten, that is 340 times 10 power of 28 times 1.60 times 10 power of negative 19. So we have 3.121 times 10 power of negative 4 meter per second. Okay, so number 3, time taken for electron to move from one end to other end of the wire. So we have a wire over here. So what would be the time for one electron to move from this side to other side? Okay, so you have V equals to D over T, velocity equals to displacement over time, and T equals to D over V. So displacement is 3 meter, wire is 3 meter, divided by velocity is 3.121 times 10 power of negative 4. So it will be 9,612.30 seconds. Okay, it's a big number. It's not in 1 hour, more than 1 hour for one electron to move from one end to one end in 3 meter. It's too slow. Right. Okay, until question number 16. Any question about this question number 16? Everyone clear with the answer? Abi? Sure, okay. Okay, we also
Yes, sir.
question number 17. Okay. This is very easy. You can see this is the marks 2, 3, 1, 1. So it's not very. Don't think it too deep. Okay. For 13 current is represented by equation I equals I naught sine omega 2 omega f 2 pi ft. You know that is omega t. 2 pi f. Okay. On the same basis, sketch a graph of I against t and I squared against t. Okay. Same axis. So you have to one single graph, two graph. One single axis, two graph. Okay. So you have here axis one. Okay. So we do with I first. I against t. So I against t, you know that I is using I naught as is a maximum value, and we know that it's using sine. It's not using cos. If using cos, we start with maximum, then going down to the minimum. So with sine, we are using from the zero to going up. So it will be in this way, going up and down, and goes back again up. Okay. So we have to label all the x's. If not, you cannot get any marks. So this is a t, one period. This is t over 2. And the maximum point, the peak point will be I naught. Okay, you have to show that this one. You have label. And again, you have to label this is t, this is I. Okay. I squared against t. I squared means that any it will be bigger than I naught, of course. I thinks that's a double or a times power of 2 will be bigger value. So first of all, for the second one, I naught will be bigger like this, right? Because okay, I put here I naught squared. So I naught squared will be bigger first of all, and then when we have I naught, the negative parts, negative face will be flipped to the uh, positive face. So you see going up here and then goes up, and the negative face or negative part of the graph will be flipped over because it's a square. So it will be like this. So actually this is not a good drawing. It must be the same face. Maximum will be same. This maximum should be the same as this one. So it will be same line vertically. Okay. So this will be the answer. Okay. Forgot one more. It should be value on the bottom. This one will be I naught. This is not I naught square. It's I naught. Okay. So this is 17A. Answer for 17A. Find the mean value of B. Find the mean value of 1 I and number 2 I. So mean value of I. Okay. Mean equals to 0. It doesn't have any mean. Okay. And number 2 I squared. I squared will be I squared mean will be 1 over 2 I naught squared. So this is I naught. You divide it by 2. Then you have the mean of it. Okay. Half of I naught squared. This is. Okay. For because so you see this is 1 mark, this is 1 mark. So answer will be a very simple answer. Any question? Any question? Hmm. Now, Usha, you have any question about question number 17?
No, sir.
Okay. So anyone got correct? On I think most of you got correct. On question number 17 is easy. Okay, question number 18. You have a several capacitor. Each capacitor is 20 microfarad. In each case, draw a diagram to show how you will connect a suitable number of this capacitor in order to obtain the capacitance of 10 microfarad, 30 microfarad. Okay, so remember, adding up the capacitor when you have a capacitor that in series. Oh, sorry. When you have a capacitor in series, oops, okay. When you have capacitor in series, will be R 1 over R. T equals to 1 over R 1 plus 1 over R2 and so on. When you have capacitor in a parallel, okay, capacitor will be RT equals to 1 R1. Why I'm using R? It's not R, it's C. See, when you are fasting, your mind has lesser energy to think. Okay, this is 1 over C, T, C, and C1 and C2. This is Ct equals to C1 plus C2. Okay, see? Nobody uh, try to correct my mistake. Okay. Okay, so we have two ways of connecting a capacitor, and so A1 will be the answer will be in series. Okay, capacitor with 20 microfarad. This is, it says, using only 20 microfarad, and one more is using 20 microfarad. So you add up this one, you have a 10 microfarad. Mm, 20 plus 1 over 20 plus 1 over 20. So, and flip it over. So this is 2 over 20. This is 1 over C. C equals to 10 microfarad. Okay. And number 2, it will be series and parallel. Okay. So it will be 20, 20, 20. So you have to combine these two again. So this one will be 10, and 10 plus both of them will be 10, and 10 plus 20, because it's in parallel, will be 30 microfarad. So this combined to with 30 microfarad. So this will be the answer for 18A. So B, 18B, a capacitor of capacitance C has charge Q and potential difference across its places V. The energy W stored in energy capacitor is given by W equals to half QV. Write the expression C in terms of Q and V. So it's one mark only. Okay. So B1, write an expression of C. So C in terms of QV, just like C is equals to Q over V. And now obtain expression W in terms, so use W over here in terms of C and V. So W equals to half QV. So Q is CV and V, so half CV squared. So this is only 2 marks. Okay, so that's it. Question number 18C. Automatic lamp operates totally discharging a capacitor. The capacitor is discharged from a battery times quarter, and charging circuit is 4 seconds. Okay, the automatic lamp will only function correctly when capacitor is charged, so that it stores at least 80% of energy from the fully charged capacitor. Okay, time constant. He says that time constant charging circuit is 4 seconds. 4 seconds is not fully charged yet. Okay, it's not fully charged yet. So remember that some students tend to imagine that 4 seconds is the time of the fully charged. It's not. Okay, so 4 seconds is actually how much is it? Uh, is 1 over E. 1 over E of the, and 1 over E, and E is uh, 1 over exponential. of the whole thing. So it's 4 second is not the full charge. Okay, the full charge of the of the capacitor. It's not yet. So this is a CR equals to 4 second. Okay. Uh, so the capacitor needs at least 80% of energy to fully charge capacitor. Okay. So what fraction of battery voltage must the capacitor be charged if the automatic lamp is to function correctly? So how much fraction of battery voltage must be fraction battery must the capacitor to be charged? So how much battery voltage to put into the capacitor to the automatic lamp to function correctly? So this is 3 marks. Okay, so we put as a V is a voltage across capacitor. Okay, and W over W naught. Okay, equals to 0.0. So this is the input, and this is the output. Output per input per output. Okay, so it will be 0.80. 0.80 because we have 80%, and so we have W equals 1 over CV squared over 1 over CV naught squared. So this one will be 0.80. Okay, so V, yeah, we have the same thing over here. So V, we can cancel the C and half. So V squared, V over V naught uh, is equal to square root of 0.80 because both of them is squared, and equals to 0.89. Okay, so the capacitor must be charged to about 0.89 of the battery voltage. Okay, so it must be charged 0.89 of the ratio to the battery voltage, then it can be function. Question number 2. What is the minimum charging time for the capacitor before automatic lamp can be used again? So how much the time? Minimum charging time. So we use the uh, charging formula, voltage charging formula. So V0 equals to 1 over E minus proportional T over CR. Okay. So V over V0 V equals to 1 minus E negative T over CR. Okay. And it has a value of 0.89 because V over V0 will be equals to 0.89. Okay. 89. E equals to minus power of T over CR equals to 0.11. So T equals to negative ln 0.11 times 4, and equals to times 4 equals to 8.83 second to this answer. 8.3 second to charge the capacitor because it can be used again. Okay, state 2 function of dielectric in the capacitor. Sheridan, are you there?
Yes, sir.
Okay, what's the answer for D?
My paper is downstairs, sir.
Hmm? What is the function of dielectric? There are 2 marks. One is
To increase the capacitance, effective capacitance of the capacitor.
increase the capacitance. Correct. Increase the capacitance of the capacitor. Number 2. Hmm? Number 2.
Uh,
Acts as an insulator To
between
prevent,
the plates
yes, to prevent the plates
from touching.
to
From
uh,
touching.
from touching, huh? Touching. Okay. So that's it. 1 and 2. Thank you. Okay. So 18D. Uh, 19. Define magnetic field strength P in terms of the F, the X or conductor length L carrying current I. Uh, 19.1. Define electric field strength P in terms of force, the X conductor length L. So it means that it has a relation of we have a conductor with L, the force, okay, and the conductor current. Conductor is carrying a current, which I, and we have a force of it, and we have a B, this area. So the current carrying conductor is in the magnetic field. Okay, define magnetic field. So you can say that the magnetic field strength B is the force F that acts on a wire of length L, which carries a current of I when the wire is placed perpendicular to the magnetic field. Okay, so that's it. B. Starting from variation 1, derive expression for the force charging moving in the magnetic field. So number 2, this is number 1. Number 2, so N will be the number of free uh, electron per unit volume. Okay. A will be sectional area of wire, and V drift velocity, and Q will be charge, and big N, capital N, will be the total free electron in length. uh, Ft will be the total force acting on all charge. Okay, so it will be, this is very long, F equals to Ft, okay, over N, okay, Ft over N, and Ft is the total force on the charge with conductor L, okay. So Ft over N, and N is the big N is total free electron in L. Okay, so Ft is actually NBQV over N. So you cancel out the N and you have QVB. So F equals to QVB. Okay, that's it. Okay, it's very long, but you have to make a definition here. 1, 2, 3, 4, 5, 6. 6 definition. But marks is too little of marks. Never mind. continue with 19b. 19b, in a certain region where its magnetic field charge moving constant speed without a deflection in this space. So which of the following two conditions can be given? B0, E0. I need somebody to help me. Over here, B0, E0. Is it true or not? It's true or false? Usha or Yukin? For number one, B1. A certain region where its magnetic field and speed of a variable magnitudes. A charge is moving constant speed without deflection in space. With the following two conclusions given, below is correct. Yukin and Wisha. B0 magnetic field is 0 and electric field also 0.
Sir, no forces acting on the electron.
No forces.
Resultant forces acting on the electron.
So no forces.
Acting on the electron. Is that true?
No forces acting as long means that either B or E0.
Yeah. Both are 0.
Which of them is correct? So actually, if B0 and E0, okay, a charge can be constant speed can be moved without reflection of constant speed. Okay, see, you say there is no forces, right? No forces. It means that B is 0 and E also 0, right? Yukin, this is what you meant.
Yes, yes, yes.
Okay.
Yeah.
But if, let's say if we have E and B is cancelling each other. So we have E pointing down and B pointing to into the into the into the screen pointing, and both of them is cancelling. Force of E is cancelling force of B, right? Both of them has a value. E has a value and B also has a value, but they are cancelling each other. So a charge also moving in the constant speed, right? Why not?
Yes. Yes, correct.
So you cannot say B is 0 and E is 0. Then we have a constant speed. It can be a value of B and E, but both of them is cancelling each other. So
Oh.
is it true or not? This statement, is it true or not for you? True or false?
I think true.
True or false? I already given you the explanation here.
False, 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 false.
False. It
False.
will be false. Okay. There are two. The electron will be in straight line either two ways. Either is E0 or B0. There's no forces of B and E, or Fe, force of Fe equals to Fb. So both of them are cancelling each other. So this electron will be moving in a straight line. Okay. Okay. B number two. Magnetic field 0 and E is not 0. So the charge is moving at constant speed. So this one is true if velocity is parallel to the B. Okay, it's parallel to the B. Of course, it will not be having any deflection. You always if we are perpendicular to the B, then we're having a deflection. Number 3, if both B and E are not 0, show how we can change concept without deflection. Occurs, this is number 2, will occur when E, electric field, is perpendicular to B and V equals to E over B. Then we have a constant speed, okay, where actually the E will be cancelling the B. Force of E cancelling the B. Okay, I got a notification from Zoom. Going to stop for now. So tomorrow we have a class, the same time. How many came today? Vishai, Keshika. Okay, 1, 2, 3, 4, 5, 6, 7. 7 students for today. Okay, so we'll see you tomorrow. We continue with 19C. And same time at 4 o'clock. Okay, see you tomorrow. Bye bye.
Okay, thank you, sir.
Thank you, sir.